Look at the southern tip of Spain and the northern edge of Morocco. The physical gap separating Europe and Africa here is incredibly narrow. On a clear day, you can stand on the Spanish coast and see the African mountains with your naked eye. The distance across this stretch of water is exactly 14 kilometers. This map highlights the massive global commerce funneling through this corridor. It's a choke point handling 33% of the world's oil and gas, half of all global maritime trade, and 80% of the EU's merchandise. Connecting these two landmasses would yield a massive logistical payoff. A physical link could cut the travel time for goods moving between Casablanca and Madrid from 12 hours down to 5.5 hours, creating a high-speed overland corridor for the first time. Spanning 14 kilometers over water is well within our current technical reach. For context, engineers in China recently completed the Hong Kong-Zhuhai-Macau Bridge, which stretches 55 kilometers across the ocean. Even digging deep underwater is a proven science. Over 30 years ago, the UK and France successfully bored a 50-kilometer tunnel directly beneath the English Channel to connect their landmasses. The failure to physically connect Europe and Africa has nothing to do with the distance. The Strait of Gibraltar is a unique engineering nightmare that has systematically dismantled every blueprint proposed over the last century. The first serious effort to bridge the continents was proposed in the 1920s by a German architect named Hermann Sorgel. His idea, Project Atlantropa, bypassed conventional bridges entirely. He wanted to physically alter the ocean itself. Sorgel's plan was to build a colossal hydroelectric dam across the strait. By blocking off the Atlantic, he calculated he could lower the water level of the Mediterranean Sea by 660 feet, exposing enough seabed to physically merge Europe and Africa into a single supercontinent. The proposal failed. Draining the Mediterranean would have triggered ecological devastation. Testing the concept alone would have cost billions of dollars, and the construction technology of the 1920s wasn't capable of managing the water pressure. Fast forward to the late 1970s. Spain transitioned to a democracy, and by 1980, King Hassan II of Morocco and the Spanish government joined forces. They set up public companies to survey the strait and design a straightforward 14-kilometer traditional bridge. Their survey ships immediately ran into violent ocean physics. Here, warm, buoyant Mediterranean water violently collides with dense, cold meltwater flowing in from the Atlantic. This difference in density generates intense, swirling convection currents that snapped drill rods and made it nearly impossible for vessels to drop anchor. Once engineers finally managed to map the seafloor, they hit a geographic dead end. This cross-section compares the 180-meter depth of the English Channel with the 14-kilometer short route across Gibraltar. The strait plunges down 900 meters. To build a bridge here, every support pillar would need to be 3 Eiffel Towers tall just to reach the surface. If you look closely at that deep seabed foundation, the second problem becomes obvious. The ocean floor isn't solid rock. It's made of a material called breccia, a porous, weak mixture of clay and loose stones. Worse, this fragile sediment sits directly on top of the active fault line, where the African and Eurasian tectonic plates constantly grind against each other. Building a traditional bridge or tunnel on the shortest route is physically impossible. It would mean constructing a skyscraper on quicksand, sitting directly over an active earthquake zone, under nearly a kilometer of violent ocean currents. In the 1990s, an American architect named Eugene Sui proposed a radical alternative. Since foundations cannot be anchored deep in the seabed, the only option left is to build a structure that floats on the surface. Sui designed a flexible, floating bridge, operating like a giant sea serpent, featuring underwater tunnels that bend and absorb the ocean's violent currents, eventually surfacing in the middle of the strait to connect with a massive 3-mile-wide artificial island city, powered by windmills and solar farms. But this floating structure collided with the economic reality of the strait. Because huge oil tankers and aircraft carriers pass constantly, any bridge built here requires at least 70 meters of vertical clearance for vessels sailing underneath. Upgrading a floating structure to handle active ocean currents while safely elevating a massive roadway 70 meters into the air pushed the estimated cost of the project to a staggering $20 billion. The floating bridge was abandoned. It proved that engineering ingenuity cannot bypass the strict physical dimensions and extreme financial scale required to keep global shipping lanes open. By the early 2000s, engineers realized the 14-kilometer route was the wrong choice. They abandoned the shortest path and shifted their focus further west to a 28-kilometer stretch known as the Threshold Route. This map highlights the shift to that longer western path. Despite being twice the distance, this route is only 300 meters deep. Most importantly, the seabed here is composed of a hard, stable rock foundation. The engineering challenges had been answered. Rather than a bridge, they would bore a 3-tunnel railway system straight through the rock. In 2006, a Swiss engineering firm officially won the contract to start construction. But as a century of geographic obstacles were overcome, the project was derailed by human politics. Even though Morocco gained independence in 1956, Spain retained control over 2 key territories, Ceuta and Melilla, which sit directly on the Moroccan coast near the strait. In 2008, the Spanish king visited these enclaves, sparking diplomatic outrage from Morocco, who immediately withdrew their ambassador and halted the tunnel project. A similar political dispute halted the project again in 2020. Today, global powers, including the US, EU, and China, are placing immense pressure on both nations. With global supply chains dependent on this choke point, an alternative trade route is seen as critical to preventing a worldwide economic crisis if the strait is ever blocked. Humanity has solved the depth, the violent currents, and the unstable soil, but the project remains stalled by territorial disputes, dividing Spain and Morocco for decades. Until those borders are settled, the 14-kilometer gap remains the world's most expensive short distance.